Hello and a warm welcome to all the participants, students and viewers. Right? Welcome back to the YouTube live session for your revision series preparation for your university examination. Right? So what is our main idea here? The main idea here is to give a insight of what are the different topics which are important, how you should prepare it, and what and how you should write in your university examination to secure a good marks, right? So here we are going to discuss all those things. So again, welcome back. I hope all of you are doing great. If you remember last time when we met, we talked about torsion, right? We talk about torsion, how you should derive torsion formula, what is torsional stress, what is the different parameters there, and how to calculate all this using numerical example I have given to you, right? So if you didn't watch that video yet, what you can do is you can go to Ace Engineering College YouTube channel and you can find that video. Or else what I will do is I will give the link of that video at the description, right? So let's start the today's session. What is the today's session topic? So today we are going to talk about a very interesting topic, that is nothing but springs. That is nothing but springs. You all know that this is a topic, or this is a thing which we come across day to day in our day-to-day life. Yes? So first we'll understand what is a spring. If I ask you define a spring, how will you define it? Simply, how will you define a spring, or what is a spring? So if you know that where we use that, if you remember that, you can easily write the definition from there. So if you ask me what is the definition of a spring, definition, what I can say, definition or define definition of a spring, definition, it is very easy. Spring is a device, spring is a device to store energy. To store energy. It is a device to store the energy. And the spring not only stores the energy, it will release it back when it is needed, or you can say when it is required, it will release it back. So spring will not only store the energy, it will release it back whenever needed. Whenever you need that energy, it will give you back. That is the simple definition of spring. You can say this one and you can easily make anyone understand what is a spring, right? Next, here one interesting topic. Since it will store what? It will store energy. So here one important topic of strength of material come into picture, that is strain energy. Whenever I talk about energy in strength of material, mostly it is related to strain energy. So for this topic, you have to know the little bit of your strain energy. What is a strain energy? How to find out strain energy for different type of forces. If you know that much, this topic is very easy or comfortable. Don't mind if you don't know also, we are going to discuss whatever needed for this session, right? Okay. Now, whenever I talk about strain energy, there are two terms come into picture. One is resilience, another one is toughness. What is resilience? What is resilience? Resilience is the maximum strain energy stored within a elastic limit. And what is toughness? The strain energy stored till fracture point. Right? Now my question is here, if you want to make or if you want to design a spring, whether you will make it for high resilience or you will make it for high toughness. That means how you should design it. So always remember, we will design for high resilience. Why? Because what is resilience? Resilience means strain energy stored, maximum strain energy stored up to elastic limit. If it is up to elastic limit, that means the moment you release it, it will come back to its original position. So the maximum energy we can store without getting deformation is resilience. So I can write spring will be designed for spring will be designed for spring will be designed for high resilience. High resilience. Right? So this is all about introduction, or you can say how you should define it. Now coming to the next topic, which is important because short type of answer, maybe 2 marks or 3 marks question may be asked from this topic. What are the different types of spring available? So basically the spring is divided into 2 types. The first one is laminated spring. The first one is called laminated spring. The another name for laminated spring is leaf spring. What we call leaf spring. So let's see how a laminated spring look like. So if you see a truck, means 6-wheeler or heavy duty vehicles. If you see in the back side or in near to the wheel, rear wheels, you can see this kind of arrangement. What is this arrangement? These are metal plates kept one over the other. Okay, small plate down and bigger length plate at the top. So this setup, what you can see is here, that is nothing but laminated spring. And I said it is also known as leaf spring. Leaf spring. This is also known as leaf spring. Okay, so this is laminated or leaf spring, and another type of spring is called as helical spring. Another type of spring is called helical spring. So there are basically 2 types of spring, laminated, helical. Now this helical spring is again subdivided into 2 parts. The first one is open coiled helical spring and the second one is closed coiled helical spring. So here there are possibility of asking 2 different sets of questions. The first one is give different types of spring. Then it is very easy, you can write it that there are 2. One is laminated spring, another one is helical spring, and helical spring is again subdivided into 2, that is open coil helical spring and closed coil helical spring. But there is another question which may appear, or which most of the time appear, is differentiate between open coil helical spring and closed coil helical spring. So in this live session, our complete discussion will be limited to helical spring only. Today we are going to discuss about helical spring. This topic will take later, right? So open coiled helical spring and closed coil helical spring. So first we'll see how it will look like. So if you see, this is a figure of open coiled helical spring. This is a figure of open coiled helical spring. And if you see this kind of spring, this is called closed coil helical spring. Now I am pretty sure that by looking at the figure, you can easily guess where we are using this one. So very easy guess. If you most of us used ballpoint pen. So in that pen, sometimes we need to press it. That is spring based ball pen, where we need to press the top of the pen so the nib will come out, right? And again, if we press it back, the refill will go in. So if you ever open that one and if you see, there will be a spring that look like this. So first thing I can say, that whenever there is a need of compression, or when there is a compressive force acting and you need to apply a spring over there to store energy, so which type of spring you should opt? You should opt open coiled helical spring. So this is also called as, this particular spring is also called as compression spring. This is also called as compression spring. Okay. So if they have given you a spring and they said in that compressive force is acting, so you can obviously tell that it is a open coiled helical spring. Whereas this kind of spring, where we use it in the hair clip. Girl student will know better because they use hair clip. In the hair clip, if you see backside, there will be spring like this. Yes, then boys, if you ride bike or scooty or bicycle, how you make it stand? If you just see the stand, when you stand your bike or bicycle, if you see, there is a spring attached with the stand. That is nothing but a closed coiled helical spring. And this type of spring is used when there is a tensile force. So this is also called as tension spring. This is also called as tension spring. This is also called as tension spring. Right? Okay. Now this is the first differentiation. Right? Next. So when you apply a load in this, what will happen? There will be an effect. Yes or no? There will be effect or not? Yes. So the effect of load in the spring, when you put or when you apply a compressive force in the open coiled helical spring, what will be its effect? It will bend, at the same time torsion will come into picture. So the effect here, effect of load is both bending and torsion. So when you apply the load, this kind of spring will have both bending and torsion. But when you apply a load in closed coiled helical spring, the effect will be both bending and torsion, but the predominant is torsion. So here the effect of torsion is predominant in closed coil helical spring. So these two are the main difference between open coil and closed coil helical spring. Except these two, there are some more. So the third one is the helix angle of open coiled helical spring is more than 10 degrees. So helix angle is more than 10 degree. So what is helix angle? First understand. So if you see this coil, we call each round as coil coil of a spring. So if you see, this coil are not in a straight line. This is not straight. This is in a angle. So the angle made between the coil and the horizontal, this angle alpha, we call it as helix angle. So the third one here, if you see here, the helix angle is more compared to here, helix angle is more in open coil helical spring. So simply I can write the third one, helix angle is less than 10 degree. The helix angle is less than 10 degree, right? So these are the three. Next, coming to the next differentiation, fourth one. What is the fourth differentiation? Fourth. So now you see, the center of one coil, the distance of center of one coil to another adjacent coil, we call it as pitch. From the center of this point to this is called pitch. So you can see, pitch is more in case of open coil helical spring, whereas pitch is less in case of closed coil helical spring. So you can write pitch is more, and here fourth point you can write pitch is less compared to your open coiled helical spring. And last but not the least, you can say by looking at the figure that there is a gap in between the coil. You can see, right, here there is a gap, here there is a gap, here there is a gap, here there is a gap. But if you see the closed coil helical spring, there is no gap at all. So what you can write like this, fifth one, the coil is wounded in such a way that there are gap in between the coil. Whereas if you see this side, there are sufficient gap. There are no gap means this one. There are sufficient gap. There are sufficient gap. In between the coils. There are sufficient gap in case of open coil helical spring. But if you see closed coil helical spring, there are no gaps. So you can write it like this. Fifth one, the coil is wounded in such a way that there are no gap in between the coil. So if you write this 5 differentiation, my friends, if you write only this 5, I can guarantee you that you can get full marks, or you can just write like this, the questions will be over. It is very easy, just this 5 difference, right? If it come for 5 marks, easy, and draw the diagrams. Diagrams are quite easy. You have to show some gap here and here no gap. That's it, my friend. So this is the short answer question which you may get in your university exam, right? Now we'll talk about closed coil helical spring in detail, right? So you all know that closed coil helical spring, the effect of torsion is predominant. So I can write for closed coil helical spring, we also know that torsion is predominant. Torsion is predominant, right or not? Yes, torsion is predominant. Now, if there is a torsion, there will be shear stress, or you can say if there is a torsion, there will be 100% torsional shear stress. So obviously the spring will subjected to what? Spring will subjected to torsional shear stress. Spring will have a stiffness. Yes or no? If it is subjected to torsional shear stress, then what should be the maximum shear stress for a spring? Spring will have a stiffness. How to find out that stiffness? Spring, due to torsional stress, there will be deflection. How to find out that deflection? So for this there is a derivation, but till now what we observe from different universities, they never ask the question to derive it. Okay, anyhow what I will do is, I will provide you the derivation, how to find out the first one, that is shear stress, how to find out deflection, and how to find out stiffness. The derivation part I will provide you in the description, but here we are not going to discuss that as it is not that important. But what I will do, I will write that formulas for you. So first we know that when torsion is coming, there will be shear stress. So the maximum shear stress, the maximum shear stress, tau max, or you can say maximum tau. Tau will be is equals to, how you are going to show this one, or how, if you derive that, you will get the value as 8WD by pi d cube, pi d cube. I will give you each and every term, just wait for some time, right? So this is the expression for tau max. You have to remember this. Tau max is equals to 8WD by pi d cube. Similarly, due to the shear stress, due to the load, there will be deflection in the spring. The deflection of the spring, the deflection of the spring, that is nothing but delta. Delta is equals to, what will be the formula? 8WD, 8WN d cube by g d power 4. This is the formula. Okay, this is the formula. So don't worry, you can easily, if you solve 2-3 questions, automatically the formulas you will remember. Don't worry about the derivation. I will provide that derivation in the description of this video later, like maybe tomorrow you will get it, because this is a live session, right? So after this session I will upload it. Don't worry about that, we will get it. Next, once we know tau max, once we know delta, the next thing is very easy. What is stiffness? Stiffness of the spring. Stiffness. Stiffness is equals to load by deflection. You all know, right? Load by deflection. Imagine the load is W. W by deflection. See, deflection formula already there. So you can simply write W n d cube by g d power 4. So what you will get, W will get cancelled. So stiffness I denote it by small k. I can denote it by small k, right? So I can write K is equals to, stiffness is equals to g d power 4 by 8 n d cube. Right. So this is my three formulas, three important formulas useful for university examination, or you can say useful to solve questions which may appear. Now here there are different terms: w, d, pi, d cube, g, n. What are those? I will write one by one. So first, what is w? W is the load in the spring. W is nothing but load in the spring. Okay. Next, what is d? D is diameter of coil. Diameter of coil. Now, which one is coil? See here, if you see this diagram, this is D. From here till here, this is the diameter D, diameter of the coil. Okay, so if I show it here, it is same. This complete circular one, that is the diameter of a coil. Right, next. Here, D over. Next, what is N? N is equals to number of coils in the spring. In the spring. Okay. So I know W, I know D, I know N. What is left? Small d. What is small d? Diameter of the wire. You all know that we use some material, maybe steel wire, maybe steel rod or something to make a spring. So whatever material you are using, that diameter is nothing but small d. So here in the picture, if I want to say this diameter is d. Diameter of the coil is small d. Okay, right. Next, G. You all know that what is G? G is modulus of rigidity. Modulus of rigidity, or you can say shear modulus, or I can say it as shear modulus. Shear modulus. Both are correct, and you know that G is a constant material property. For a material, G will be a constant value. So I know W, I know D, I know N, I know small d, I know G. So everything I know. And what is K? K is stiffness, right? So if you know this much, I can guarantee you any problem from helical spring, you can solve it, right? Again, derivation, you will get it in the description. Derivation is also easy but not required. So I am not telling you here, right? So now we know all the background, or I can say all the theoretical knowledge or all the conceptual knowledge which I required to solve numericals. Now let's start with solving a numerical, right? Now you see how to solve a numerical and what type of numerical is coming in the examination. See here. See, read this question very carefully. What is given? A closely coiled helical spring is to carry a load of 500 Newton. Its mean coil diameter. See here, I have given dia of coil. Dia of coil or mean diameter of coil is same. Capital D is mean diameter of coil, or you can say dia of coil. Both are same, right? Now you see, read that question. Its mean coil diameter is to be 10 times of the wear diameter, right? Then what they are asking? Calculate these diameters if maximum shear stress in the material of the spring is to be 80 MPa. Full stop. Also find The number of coils, they are asking number of coils in the closely coiled helical spring if stiffness of the spring is 20 Newton per mm and modulus of rigidity is 8.4 into 10 power 4 MPa. So let's solve it. We all know first we have to start with, always when you get a question, friends or the students who are going to write the exam, always make a habit of writing the given data. The moment you write given data, you will be knowing what are the values given to you. And also you will know what are not given or what you have to find out. So it is very important for everyone to write the given data first. So see here, given data. What is given data first? Load is given to you. That means W is given to you, right? So I can write W given is 500 Newton. Okay, very good. Next, they have said something about diameter, but they didn't give it directly. So here I am assume capital D is equals to mean diameter of coil and small d is equals to diameter of wear. Now once we know, or once I assume this two, now I can make a relation that its mean coil diameter is 10 times the diameter of the wire. So what is given? Capital D is 10 times of small d. This is also given to you. Right. I know W, I know D. Next, they told that it can sustain the maximum shear stress, tau max. Tau max is also given to you. What is the value of tau max given? 80 MPa, that is 80 Newton per mm square. That is also given to you. Now you have to find out this too. How you can find out? Now first I am writing all up to this much. Next part we will see this. Okay. From also to this point we will see later. First can you solve from here? Yes. Yes or no? If you see, I already given you a formula for tau max. Na? What is that? Tau max is equals to 8WD by pi d cube. Let's use this formula. So I can write, we know that tau max for a closely coiled helical spring is equals to 8WD by pi d cube. Right? So tau max value I know, see 80. I am writing here 80 is equals to 8 into W is given in the question, that is 500. That is 500 given in the question. So I am writing here 500 into capital D. Capital T given but in terms of small d. So 10 times D by pi d cube. So if you solve this one, see d and d cube, d square will be here, right? Next, if I write like this, d square. So d square is equals to 8 into 500 into 10 divided by pi into 80. Once I write like this 0 will get cancelled, 8 will get cancelled. Now directly I can write d is equals to root over 500 by pi. So if you solve this one, I think you will get d is equals to 12.61 mm. Yes or no? Yes, so this is the diameter of, wire. Once I know diameter of the wire, if I put this d value here, I will get what? Diameter of the coil. So I can write, therefore, diameter of the coil capital D is equals to 10 times small d. What is that? 10 into 12.61. So capital D is equals to 126.1 mm. This is the diameter of coil. So if you see, the first question we have solved successfully, that they ask calculate this diameter. So we found out that d is equals to 12.61 small d and capital D is equals to 126.11. Right. Now next question, what they have asked in next question? See, also find number of coils. You have to find number of coils. So now to find number of coil, that is to find number of coil. Number of coil is denoted by small n. So I have to find out this. I have to find out number of coil, small n value. How to find out? To find out this one, they have given that stiffness K is equals to 20 Newton per mm. See, in the question it is given here. The stiffness of the spring is 20 Newton per mm. And in addition with G is also given to you. What is G? That is 8.4 into 10 power 4. So they have given you G, they have given you K. 8.4 into 10 power 4 Newton per mm square. Now how to find out? So here, if you find out, see this three relation, if you see this three relation, what you can get from here? Can you find out? If you use this equation, delta you don't know, W you don't know, W you know, but N also you don't know. So two unknowns I cannot. But if you see this relation where stiffness is given, so K is equals to G given in the question, small d we just found it out, 8 is a constant, N we have to find out, capital D also we know. So we can use this relation and find the value. So here I will write, therefore K is equals to G d power 4 by 8 n d cube. Right? If you use this relation, you will find it out. So K is 20 is equals to G 8.4 into 10 power 4 into, what is small d value we got? We got small d is equals to 12.61. So 12.61 power 4 divided by 8, n is unknown, and d cube 126.1 cube. So solve this one. I can write n is equals to 8.4 into 10 power 4 into 12.61 by 8 into 20 into 126.1 cube. So I hope if you solve this one, you will get the correct answer, right? So if I say What will be the answer you will get if you solve this one? I think you will get something around n is equals to 6.62. I think you will get this one. But is it possible to give 6.62 number of turns? No, it is not possible. Number of turns either will be 6, 7, 8. In decimals we can't, right? So here we need to round it off to the nearest higher value. So 7. So I can simply say, therefore, provide 7 number of turns. Provide 7 number of turns, right? So this is the solution of this given question. Very easy. If you do like this, like if you write the given data first and if you remember those 3 formulas, it is very dead easy question, right? Yes, very good. Now we'll see one more question, but this time little bit tricky one, right? Little bit tricky one, and that kind of question only mostly asked in the question. This is also a university question, but I am saying that we need to practice for the toughest one, right? So let's see the trickiest one. See, this is the question. What is given? Read it. A closely coiled helical spring of mean diameter 20 centimeter. For you, mean diameter is given. Then is made of 3 centimeter diameter wire. So diameter of the wire is also given to you and has 16 turns. Number of turns also given to you. Now read it. A weight of 3 kilonewton is dropped on the spring. Find the height. Find the height, very important, by which the weight should be dropped before striking the spring so that the spring may be compressed. The spring may be compressed by 18 centimeter. Take G is equals to this one. So here there is a situation given to you. Let me draw that and tell you what is that situation. Imagine I have a spring here, right? This is the spring. Imagine this is the spring I have, which I fixed at the bottom, right? And here there is a small platform, right? So in this spring there is a weight of 3 kilonewton. So there is a weight of 3 kilonewton. So this is a block which weight 3 kilonewton. What they are saying is, suppose this 3 kilonewton dropped from a height. You have to find out that height only, such that what happened when that 3 kilonewton hit this spring, there will be a compression. There will be a compression in the spring of 18 centimeter. 18 centimeters. See, they have given it is compressed by 18 centimeters. So what happened when you drop this one from this height? There must be a compression. So there must be a delta which is equals to 18 centimeter. They have told this one. So what they are asking, to get this compression of 18 centimeter, from what height I should drop this 3 kilonewton. This is the question they have asked, right? Tricky question. Now you might be thinking, sir, how to use those 3 formulas and find it out. Good. But here you need to not only use those 3 formulas. As I said, spring is a chapter which is related to strain energy also. So here we need to use the concepts of strain energy also, right? So first tell me, when 3 kilonewton I dropped it from here, so this 3 kilonewton will do a work done. What will be that work done? Work done by this weight of 3 kilonewton. Can you tell me what is work done? Load into distance. So what is the load? 3 kilonewton is the load. So I can write here first, the relation is work done by 3 kilonewton load. The work done of this 3 kilonewton load must be is equals to what happened when this 3 kilonewton hit the spring? It will compress. Compress means it is storing the energy, na? So work done by this 3 kilonewton load must be is equals to strain energy stored in the spring. Strain energy stored in the spring. So if you get this one correct, if you understand this one correct, remaining thing is easy. So just you should know, or you understand that when there is a load dropping over a spring, there must be a work done. And what I said, spring is a device to store the energy. When there is a work done, there must be some energy stored in the body. So that whatever the energy stored in the body must be equals to the work done. So work done by 3 kilonewton load must be equals to strain energy stored in the spring. With this concept, we are going to solve this one, right? So here, first, this 3 kilonewton load dropping over a spring, this is a concept of impact load in strain energy stored in a body due to impact load. You might have learned this concept, right? Now, let's write as usual first the given data. What is the given data here? Given data. See here, given data. First, mean diameter of the coil is given. Capital D is given 20 centimeter. Let me change everything to mm. So, 200 mm. Right. Next, the diameter of the wire is given. Small d is given 3 centimeter. Let me change into mm. That is 30 mm. Right. Next, it has 16 number of turns. So, small n is given to you 16. Right. Next, a weight of 3 kilonewton is dropped. So, weight dropped, I am writing it as P, which is 3 kilonewton. 3 kilonewton is nothing but 3000 Newton. Right. Now, next is delta. Delta is given. Delta is equals to 18 centimeters. So, if I change it, it will be 180 mm. And at the end, G is given to me. That is 8 into 10 power 4. 8 into 10 power 4 Newton per mm square. Right. Now, here, see, if I want, these are the given data. Once I know the given data, this is the situation, and from this situation, I know I need to use this relation. You can call it as energy conversion relation, or I am just converting work done into energy. Now, what is work done? Load into distance. So, load is weight drop, that is P, right? So, here work done, okay, let me write in the next slide. Okay, work done must be equals to strain energy. So, I am writing here work done by 3 kilonewton load must be is equals to strain energy stored in the spring. Now here, what is work done by 3 kilonewton load? First, work done is nothing but load into distance. So if you see this diagram, this is the load. How much distance it traveled? H plus delta. So I can write work done by 3 kilonewton load is nothing but load P into distance H plus delta. Whereas strain energy stored in the spring. What is strain energy stored in the spring? If you remember, half into load into deflection. Now here, the very important, most of the students did a mistake. They consider here strain energy stored in a spring, that is this formula, this load is equals to 3 kilonewton. No. This strain energy stored in a spring is nothing but half into load into deflection. But this load is not 3 kilonewton. Why, sir? Because this equation is valid for gradually applied load. Gradually applied load. This is valid for gradually applied load. So how I am going to use? So we know that this is the situation, 3 kilonewton is dropping. Now what I am saying that, imagine there is the spring like this. How much load I should place here gradually? How much load I should place here gradually so that I will get exact 18 centimeter. Once I know this, then work done by this spring must be equals to this. So I have to find out how much gradual load I have to place in the spring, so that gradual load, not impact load. This is impact load. This is gradual load. So how much gradual load I have to place in the spring to get 18 centimeter deflection. That I have to find out first. So here this load is nothing but W. So first task is how to find out W. So for that they have given us delta. So I know that, I am writing here, we know that delta is equals to 8W n d cube by g d power 4. Correct na? Yes. So here I know delta. What is delta? 180 mm is equals to 8 into W. I have to find out, into n, number of turn given in the question, 16, into d cube. D is also given in the question. See here, 200 mm. So 200 divided by G. What is G? 8 into 10 power 4. 8 into 10 power 4 into small d, that is 30 mm. So 30 power 4. So if you solve this one, you will get what is the W from here. So very easy relation, yes or no? Yes. So W is equals to how much you will get? I think you will get 11390 Newton. You will get W is equals to 11390 Newton. So if I place 11390 Newton gradual load in the spring, I will get 18 centimeter of deflection. So now I will use this one, this equation, that is nothing but, now if I use, now I can write P H plus delta is equals to half into load. What is the load? 11390 into delta. Deflection, same. So let me write W only here. In the next step, we'll write this W. Now here P is given 3 kilonewton. So I am converting into Newton, 3000. Height I have to find out. Delta is 180 is equals to half into W I know, that is 11390 into delta. What is delta? Again 180. So if you see, there is only one unknown, that is height, h. So if you calculate h, you can easily find out this h is equals to 161.7 mm. Right? So I think this is the result. So this is what they ask in the question. What should be the height from which I need to drop that 3 kilonewton load? Right? So this is the solution. I hope it is clear. Right. So this is the trickiest one in this chapter, if I say, because this needs the concept of the other chapter too. So I hope you understand this one. Right. So next, see the last one, last question. See, this question is very simple. You can solve easily. A closely coiled helical spring made up of 10 mm dia steel wire. So given data, what is given to you? They have given that small d is equals to 10 mm, right? And has 15 coils. So n is also given, that is 15. And 100 mm mean diameter, capital D given 100 mm, right? Yes. Next, what given? The spring is subjected to a load of, axial load of 100 Newton. So W is also given to you 100 Newton. Now what you have to find out then? Maximum shear stress. Very easy. First question. Tau max. You all know formula. Tau max is equals to 8 WD by pi d cube. 8 W is given 100 into W is also 100, D is also 100, okay, divided by pi into 10 cube. Solve it, you will get the value. Tau max, so whatever answer you will get, I use Newton and mm, so you will get the answer in Newton per mm square. I think you can solve it, right? Okay, next, second question, the deflection delta. Deflection is equals to 8 Wn d cube by g d power 4. So for this again 8 into W. What is W? 100. N is given 15 and D is again given 100 cube by G. G is not given? Yes, G is also given. See here, G is also given. 8.16 into 10 power 4 into D, small d, 10 power 4. Again, you will get some value and the answer will be in mm because I used only Newton mm, right? Next, third one. Third one is stiffness, K. K is equals to W by delta. Either use this one or instead of this you can use G d power 4 by 8 N d cube. You will get something value in, you will get something in Newton mm. Newton per mm. So if you solve something, you will get Newton per mm. So I hope you can solve this 3 easily, right? So you can see all the questions are basically round about these 3 concepts, or you can say these 3 formula. This is the second one which I showed you is little bit tricky, but if you understand this concept, quite easy, right? So with this topic also finishes here. I hope you have understand the concepts. I hope you have understand the numericals. In case you have any doubt, kindly comment. Comment section is open for all of you to ask any kind of queries. If you ask in comment section, what I will do in the next upcoming video, I will take up your questions and give the solutions for that. Okay, or I will give the explanation in the upcoming video. So kindly go through this one more time. If you able to understand, very good. If you enjoyed this session, please hit the like button, share it with your friends, classmates and all, and also subscribe to Ace Engineering College YouTube channel, because every Saturday we are coming with new topic explanation, new subjects, new topics, and our team will always support you in all the queries, right? So all the best. Hope you have enjoyed this session.